Welcome to today's episode of the California GACCs Weather Terms video series. Our topic for today will be on relative humidity and overnight humidity recovery. In this video, we will cover what relative humidity is and how it is measured, what is meant by humidity recovery, and how they are both important to fire management.
Relative humidity is defined as a measure of the actual amount of water vapor in the air compared to the total amount of vapor that can exist in the air at its current temperature. It is expressed as a percentage that can range from greater than 0 to 100%. 0% relative humidity is unattainable because there is always some amount of water vapor in the air, even if it is a minute quantity. At 100%, the atmosphere is fully saturated and holding the maximum amount of moisture that it can. This will typically lead to cloud cover and oftentimes precipitation. Very low relative humidity occurs when the atmosphere is very dry and lacking in moisture. In California, this is common under persistent high pressure, especially during the summer and fall when temperatures are the warmest. This also commonly occurs during persistent offshore wind regimes where cold and dry air from the intermountain west moves into California. The interior areas, including mountains and deserts, usually become dry first as they are far from any influence of the moist ocean air. Coastal areas take longer to dry out due to the proximity to the ocean. Changes in fuel moisture are highly dependent on changes in relative humidity and precipitation, but the timescale varies depending on fuel type. Fine dead fuels respond to humidity changes on the scale of hours, so they typically dry out very quickly when humidity becomes very low. Heavier dead fuels, on the other hand, take a longer time to respond to humidity and precipitation changes on the scale of days to weeks. Therefore, they will dry out under more persistent periods of dry weather and low humidity. Persistent dry periods also gradually dry out live fuels as well. On those shorter timescales of drying, especially in the early period of fire season in the spring months, there becomes an increased threat of grass fires with any ignition source when humidity becomes sufficiently low. As the duration of the dry period becomes longer, there becomes an increased threat for larger and more active fires and shrub landscapes, maybe even timber as well, in addition to smaller grass fires. Fire behavior and spread will likely increase as the air and fuels become drier and temperatures increase, but local wind conditions must also be considered, as windier conditions will commonly lead to an increase in activity. Relative humidity typically peaks at its lowest and most dry values in the late morning to afternoon hours, and peaks at its highest moist values during the overnight hours, especially near sunrise. The moist peak of humidity overnight is called the humidity recovery. Winds are also commonly their most calm during the overnight hours. Fire behavior typically settles down in the overnight hours into the early morning due to higher humidity recovery and less wind, so fire management tends to be easier. Overnight conditions with light winds and relative humidity above 50% help firefighters more effectively contain a fire. However, persistent dry air and gusty offshore winds prevent high humidity recoveries. Areas prone to offshore winds overnight will likely have either poor recovery or no recovery at all when a dry air mass is in place. This means that the dry conditions from the afternoon remain at similar levels or only moisten up a little bit through the night. However, areas where the wind might calm down overnight may have moderate recoveries. Fire behavior remains active with limited overnight recovery, especially with a continuation of windy conditions. Not only is knowing and understanding humidity recoveries essential for wildfire management in the extended attack periods, it is also very helpful and important for prescribed burns that may continue through the night, so effective strategies may be implemented.
That's it for today's episode of California GACCs Weather Terms. We hope you now have a greater understanding of relative humidity and associated overnight humidity recovery, and how they both impact fire weather concerns and fire management. Thanks for watching, and we'll see you in the next one.